MIME is an extension of the original Internet email protocol that lets people use a protocol to exchange different kinds of data files on the Internet, audio, video, images, application programs, and other kinds, as well as the ASCII text handled in the original protocol, the Simple Mail Transport Protocol. In 1991, Nathan Borenstein of Belcore proposed to the IETF that SMTP be extended so that Internet clients and servers could recognize and handle other kinds of data than ASCII text. As a result, new file types were added to Mail as a supported Internet Protocol file type. Servers insert the MIME header at the beginning of any web transmission. Clients use this header to select an appropriate player application for the type of data the header indicates. Some of these players are built into the web client or browser. Other players may need to be downloaded. What is MIME? Multipurpose Internet Mail Extensions is an Internet standard that extends the format of email to support texting character sets other than ASCII, non-text attachments, message bodies with multiple parts, header information in non-ASCII character sets. Although MIME was designed mainly for SMTP protocol, its use today has grown beyond describing the content of email and now often includes descriptions of content type in general, including for the web and as a storage for rich content in some commercial products. Virtually all human-written Internet email and a fairly large proportion of automated email is transmitted via SMTP in MIME format. Internet email is so closely associated with the SMTP and MIME standards that it is sometimes called SMTP MIME email. The content types defined by MIME standards are also of importance outside of email, such as in communication protocols like HTTP for the World Wide Web. HTTP requires that data be transmitted in the context of email-like messages, although the data most often is not actually email. MIME is specified in 6 linked RFC memoranda, RFC 2045, RFC 2046, RFC 2047, RFC 4288, RFC 4289 and RFC 2049, which together define the specifications. MIME is an extension of the original Internet email protocol that lets people use a protocol to exchange different kinds of data files on the Internet, audio, video, images, application programs, and other kinds, as well as the ASCII text handled in the original protocol, the Simple Mail Transport Protocol. In 1991, Nathan Borenstein of Belcore proposed to the IETF that SMTP be extended so that Internet clients and servers could recognize and handle other kinds of data than ASCII text. As a result, new file types were added to Mail as a supported Internet Protocol file type. Servers insert the MIME header at the beginning of any web transmission. Clients use this header to select an appropriate player application for the type of data the header indicates. Some of these players are built into the web client or browser. Other players may need to be downloaded. New MIME data types are registered with the Internet Assigned Numbers Authority. MIME is specified in detail in Internet Request for Comments 1521 and 1522, which amend the original Mail Protocol specification, RFC 821 and the ASCII messaging header, RFC 822. MIME headers, Mime-Version. The presence of this header indicates the message is MIME formatted. The value is typically 1.0, so this header appears as Mime-Version 1.0. According to MIME co-creator Nathaniel Borenstein, the intention was to allow MIME to change to advanced to version 2.0 and so forth, but this decision led to the opposite outcome, making it nearly impossible to create a new version of the standard. We did not adequately specify how to handle a future MIME version, Borenstein said. So if you write something that knows 1.0, what should you do if you encounter 2.0 or 1.1? I sort of thought it was obvious, but it turned out everyone implemented that in different ways. And the result is that it would be just about impossible for the Internet to ever define a 2.0 or a 1.1. Content type. This header indicates the Internet media type of the message content, consisting of a type and subtype, for example. Content type, text plain. Through the use of the multipart type, MIME allows mail messages to have parts arranged in a tree structure where the leaf nodes are any non-multipart content type and the non-leaf nodes are any of a variety of multipart types. This mechanism supports simple text messages using text plain, text plus attachments. A MIME message including an attached file generally indicates the file's original name with the content disposition header, so the type of file is indicated both by the MIME content type and the file name extension. Reply with original attached, alternative content, such as a message sent in both plain text and another format such as HTML, image, audio, video and application. Many other message constructs. Content disposition. The original MIME specifications only describe the structure of mail messages. They did not address the issue of presentation styles. The content disposition header field was added in RFC 2183 to specify the presentation style. A MIME part can have an inline content disposition, which means that it should be automatically displayed when the message is displayed, or an attachment content disposition, in which case it is not displayed automatically and requires some form of action from the user to open it. In addition to the presentation style, the content disposition header also provides fields for specifying the name of the file, the creation date and modification date, which can be used by the reader's mail user agent to store the attachment. The following example is taken from RFC 2183, where the header is defined. Content disposition, attachment. File name equals genome JPEG. Modification date equals Wednesday 12 February 1997 16:29 and 51 seconds -0500. The file name may be encoded as defined by RFC 2231. As of 2010, a good majority of mail user agents do not follow this prescription fully. The widely used Mozilla Thunderbird mail client makes its own decisions about which MIME parts should be automatically displayed, ignoring the content disposition headers in the messages. Thunderbird prior to version 3 also sends out newly composed messages with inline content disposition for all MIME parts. Most users are unaware of how to set the content disposition to attachment. Many mail user agents also send messages with the file name and the name parameter of the content type header instead of the file name parameter of the content disposition header. This practice is discouraged. The file name should be specified either through just the file name parameter, or through both the file name and the name parameters. In HTTP, the content disposition, attachment response header is usually used to hint to the client to present the response body as a downloadable file. Typically, when receiving such a response, a web browser will prompt the user to save its content as a file instead of displaying it as a page in the browser window, with the file name parameter suggesting the default file name. Content transfer encoding. In June 1992, MIME defined a set of methods for representing binary data in formats other than ASCII text format. The content transfer encoding MIME header has two-sided significance. It indicates whether or not a binary-to-text encoding scheme has been used on top of the original encoding as specified within the content type header. If such a binary-to-text encoding method has been used, it states which one. If not, it provides a descriptive label for the format of content, with respect to the presence of 8-bit or binary content. The RFC and the IANA's list of transfer encodings define the values shown below, which are not case-sensitive. Note that 7-bit, 8-bit, and binary mean that no binary-to-text encoding on top of the original encoding was used. In these cases, the header is actually redundant for the email client to decode the message body, but it may still be useful as an indicator of what type of object is being sent. Values quoted printable and base64 tell the email client that a binary-to-text encoding scheme was used and that appropriate initial decoding is necessary before the message can be read with its original encoding. Suitable for use with normal SMTP, 7-bit up to 998 octets per line of the code range 127 with CR and LF only allowed to appear as part of a CRLF line ending. This is the default value. Quoted printable used to encode arbitrary octet sequences into a form that satisfies the rules of 7-bit. Designed to be efficient and mostly human-readable when used for text data consisting primarily of US ASCII characters but also containing a small proportion of bytes with values outside that range. Base 64 used to encode arbitrary octet sequences into a form that satisfies the rules of 7-bit. Designed to be efficient for non-text 8-bit and binary data. Sometimes used for text data that frequently uses non-US ASCII characters. Suitable for use with SMTP servers that support the 8-bit MIME SMTP extension, 8-bit up to 998 octets per line with CA and LF only allowed to appear as part of a CRLF line ending. Suitable only for use with SMTP servers that support the binary MIME SMTP extension, binary any sequence of octets. There is no encoding defined which is explicitly designed for sending arbitrary binary data through SMTP transports with the 8-bit MIME extension. Thus base 64 or quoted printable must sometimes still be used. This restriction does not apply to other uses of MIME such as web services with MIME attachments or MTOM, encoded word, since RFC 2822, conforming message header names and values should be ASCII characters. Values that contain non-ASCII data should use the MIME encoded word syntax instead of a literal string. This syntax uses a string of ASCII characters indicating both the original character encoding and the content transfer encoding used to map the bytes of the charset into ASCII characters. The form is, equals, charset, encoding, encoded text, equals, charset may be any character set registered with IANA. Typically it would be the same charset as the message body. Encoding can be either Q denoting Q encoding that is similar to the quoted printable encoding, or B denoting base 64 encoding. Encoded text is the Q encoded or base 64 encoded text. An encoded word may not be more than 75 characters long, including charset, encoding, encoded text, and delimiters. If it is desirable to encode more text than will fit in an encoded word of 75 characters, multiple encoded words may be used. Difference between Q encoding and quoted printable: the ASCII codes for the question mark and equals sign may not be represented directly as they are used to delimit the encoded word. The ASCII code for space may not be represented directly because it could cause older parsers to split up the encoded word undesirably. To make the encoding smaller and easier to read, the underscore is used to represent the ASCII code for space, creating the side effect that underscore cannot be represented directly. Use of encoded words in certain parts of headers imposes further restrictions on which characters may be represented directly. For example, subject equals ISO 8859-1 Q equals A1 holler, say equals F1 or equals, is interpreted as subject, a holler, C plus or minus or. The encoded word format is not used for the names of the headers. These header names are always in English in the raw message. When viewing a message with a non-English email client, the header names are usually translated by the client. Multi-part messages: a MIME multi-part message contains a boundary in the content type, header. This boundary, which must not occur in any of the parts, is placed between the parts, and at the beginning and end of the body of the message, as follows. Mime-Version, 1.0, content type, multi-part mixed. Boundary equals frontier. This is a message with multiple parts in MIME format. Frontier, content type, text plain. This is the body of the message. Frontier, content type, application octet stream, content transfer encoding, base 64. PGHOBWW plus CIAG PGHLYWQ plus CIAG PC90ZWFK PGOGIDXIB2A5 PGOGICOG PHA plus VGHPCYB PCYBOA M9KSBVZIBOAGUGBWVZC2FNZS48L3A plus CIAG PC9IP2A5 PGO8L2HOBWW plus CG, Frontier. Each part consists of its own content header and a body. Multi-part content can be nested. The content transfer encoding of a multi-part type must always be 7-bit. 8-bit, or binary to avoid the complications that would be posed by multiple levels of decoding. The multi-part block as a whole does not have a char set. Non-ASCII characters in the part headers are handled by the encoded word system, and the part bodies can have char sets specified if appropriate for their content type. Notes: before the first boundary is an area that is ignored by MIME-compliant clients. This area is generally used to put a message to users of old non-MIME clients. It is up to the sending mail client to choose a boundary string that doesn't clash with the body text. Typically this is done by inserting a long random string. The last boundary must have 2 hyphens at the end. Multi-part subtypes. The MIME standard defines various multi-part message subtypes, which specify the nature of the message parts and their relationship to one another. The subtype is specified in the content type header of the overall message. For example, a multi-part MIME message using the digest subtype would have its content type set as multi-part digest. The RFC initially defined 4 subtypes: mixed, digest, alternative and parallel. A minimally compliant application must support mixed and digest. Other subtypes are optional. Applications must treat unrecognized subtypes as multi-part mixed. Additional subtypes, such as signed and form data, have since been separately defined in other RFCs. The following is a list of the most commonly used subtypes. It is not intended to be a comprehensive list. Mixed. Multi-part mixed is used for sending files with different content type headers and line. If sending pictures or other easily readable files, most mail clients will display them in line. Otherwise it will offer them as attachments. The default content type for each part is text plain. Defined in RFC 2046, Section 5.1.3, Digest. Multi-part digest is a simple way to send multiple text messages. The default content type for each part is message RFC 822. Defined in RFC 2046, Section 5.1.5, Message. A message RFC 822 part contains an email message, including any headers. This is used for digests as well as for email forwarding. Defined in RFC 2046. Alternative. The multi-part alternative subtype indicates that each part is an alternative version of the same content, each in a different format denoted by its content type header. The order of the parts is significant. RFC 1341 states that, in general, user agents that compose multi-part alternative entities should place the body parts in increasing order of preference, that is, with the preferred format last. Systems can then choose the best representation they are capable of processing. In general, this will be the last part that the system can understand, although other factors may affect this. Since a client is unlikely to want to send a version that is less faithful than the plain text version, this structure places the plain text version first. This makes life easier for users of clients that do not understand multi-part messages. Most commonly, multi-part alternative is used for email with 2 parts, one plain text and one HTML. The plain text part provides backwards compatibility while the HTML part allows use of formatting and hyperlinks. Most email clients offer a user option to prefer plain text over HTML. This is an example of how local factors may affect how an application chooses which best part of the message to display. While it is intended that each part of the message represent the same content, the standard does not require this to be enforced in any way. At one time, anti-spam filters would only examine the text plain part of a message, because it is easier to parse than the text HTML part. But spammers eventually took advantage of this, creating messages with an innocuous-looking text plain part and advertising in the text HTML part. Anti-spam software eventually caught up on this trick, penalizing messages with very different text in a multi-part alternative message. Defined in RFC 2046, Section 5.1.4, Related. A multi-part related is used to indicate that each message part is a component of an aggregate whole. It is for compound objects consisting of several interrelated components. Proper display cannot be achieved by individually displaying the constituent parts. The message consists of a root part which reference other parts in line, which may in turn reference other parts. Message parts are commonly referenced by the content ID part header. The syntax of a reference is unspecified and is instead dictated by the encoding or protocol used in the part. One common usage of this subtype is to send a web page complete with images in a single message. The root part will contain the HTML document, and use image tags to reference images stored in the latter parts. Defined in RFC 2387, report. Multi-part report is a message type that contains data formatted for a mail server to read. It is split between a text plain and a message delivery status, which contains the data formatted for the mail server to read. Defined in RFC 6522, signed, a multi-part signed message is used to attach a digital signature to a message. It has exactly two body parts, a body part and a signature part. The whole of the body part, including MIME headers, is used to create the signature part. Many signature types are possible, like application PGP signature, and application PKCS7 signature. Defined in RFC 1847, Section 2.1, encrypted, a multi-part encrypted message has two parts. The first part has control information that is needed to decrypt the application octet stream. Second part. Similar to signed messages, there are different implementations which are identified by their separate content types for the control part. The most common types are application PGP encrypted, and application PKCS7 MIME. Defined in RFC 1847, Section 2.2, form data, as its name implies, multi-part form data is used to express values submitted through a form. Originally defined as part of HTML 4.0, it is most commonly used for submitting files via HTTP. Defined in RFC 2388, mixed replace, the content type multi-part X mixed replace was developed as part of a technology to emulate server push and streaming over HTTP. All parts of a mixed replace message have the same semantic meaning. However, each part invalidates replaces the previous parts as soon as it is received completely. Clients should process the individual parts as soon as they arrive and should not wait for the whole message to finish. Originally developed by Netscape, it is still supported by Mozilla, Firefox, Chrome, Safari, and Opera, but traditionally ignored by Microsoft. It is commonly used in IP cameras as the MIME type for MJPEG streams. Byte ranges, the multi-part byte range is used to represent non-contiguous byte ranges of a single message. It is used by HTTP when a server returns multiple byte ranges and is defined in RFC 2616. See also, 8-bit MIME, binary-to-text encoding, direct Internet message encapsulation. A now superseded Microsoft proposed protocol intended as a streamlined MIME, primarily for use in web services. Extended SMTP, Internet Media Type, Mailcap, MIME types, Object Linking and Embedding, S-MIME, SOAP with attachments, Unicode and email, Encoding, VPIM, references. Notes. Further reading, Hughes, L. Internet Email Protocols, Standards and Implementation. Artec House Publishers. ISBN A0-89006-939-5. Johnson, K. Internet Email Protocols, A Developer's Guide. Addison Wesley Professional. ISBN A0-201-43288-9. Loshin, P. Essential Email Standards, RFCs and Protocols Made Practical. John Wiley & Sons. ISBN A0-471-34597-0. Roton, J. Programmer's Guide to Internet Mail, SMTP, POP, IMAP, and LDAP. Elsevier. ISBN A1-55558-212-5. Wood, Deprogramming Internet Mail. O'Reilly. ISBN A1-56592-479-7. External links, a more detailed overview of MIME, MIME media types, comprising a list of directories of content types and subtypes, maintained by Internet Assigned Numbers Authority. List of character sets, properly configuring server MIME types, an easy-to-follow description of multi-part messages from MH and NMH, the MIME guys, how do Internet gurus changed email forever, free online PHP MIME checker, free online MIME email validator,